Hello friends, welcome to Machine Tool Design. So let us continue from where we left off last time. Last time we had described the three equations that we had obtained by taking equilibrium of forces in the XYZ direction, and also we had described the moment equation. So today we will start with this part. Once the forces have been determined, we need to determine what is the maximum pressure and where this pressure occurs on this entire slideway. So the slideway basically would be in contact with the carriage, and over this length of the carriage we need to know what is the pressure profile. Okay, so there may be higher pressure on one side, lower on the other. Okay, so we need to be able to find this out. So therefore we would like to understand where these forces act. So we have described earlier that this may be the center line of the XYZ axis, and the forces, those are the reactions coming from the slideways, may occur either on the left or on the right of the center. So we need to know what these distances are, the XA, XB and the XC distances. Okay, so we will try to find out what these values of XA, XB, XC, which is the distance of the force from the origin. We have to basically be able to find this out. So that is our main agenda today. So let's see what the slide here says. For determining maximum pressure, it's necessary to establish the points of action of the resultant forces ABC on the respective forces. Okay, and then it goes on to say what these XA, XB and XC are. Okay, so XB should be understood to denote distance between B acting on the vertical face of flat slideway 2 and the center of the carriage. Okay, so these are all distances from the center of the carriage. So to understand this, we have already taken moment about the x-axis and utilized it to find out these directions ABC. So we will try to see the moments about the y-axis and obviously about the z-axis. Okay, so let us see moment about the y-axis first. The moment about the y-axis consists of various forces given here: Pz, Px, A, C and Q. Okay, so we would like to see them in the diagram which we have drawn here. Okay, now to just give you a quick visualization, this is how things are set. Okay, so here is your carriage. Okay, and here this is the length of the carriage. Okay, and somewhere in the center of the carriage, okay, and actually it would be along the guideway here. So I will first of all draw the x-axis. Okay, so that is your x, and along the center somewhere here, that is your z-axis, and your y-axis is in this direction. Okay, so that is the way the XYZ axes are defined, and in order to understand the moments about the y-axis, they may be the clockwise moments or anti-clockwise moments. We have to see from a particular viewpoint. Okay, so we'll have to see from the front view, and we'll look in the XZ plane. Okay, so that will help us determine all the forces and the moments about the y-axis. Okay, so having understood this, now let us see what are those forces that actually act about the y-axis. So the first thing that we see here is the force which is Py. Okay, this force Py. Okay, so this force acts at certain distance, and that distance is h. So Py multiplied by h is the first component. Okay, now the second component is also here, and that is your pz component. Okay, so this is your pz. Okay, and the pz also acts from a certain distance with respect to the z-axis, okay, or the yz plane. So therefore, if I try to understand what the distance is, we will have to try to see it in this view. Okay, and basically if your z-axis is somewhere here, okay, so it would be this distance. So this is the distance at which your pz acts. Okay, and in a bit we will basically go ahead and also see the two-dimensional diagram. So here I'm just giving you the quick visualization. There is another force which is the force q, and we have discussed what q is. Q is essentially the force which drives the carriage ahead. So this q also has a certain distance from this y-axis. Okay, so there is a certain skew distance that is there from the y-axis, and that distance has to be measured, and that would again create a type of a moment. Okay, so that is the third one. Then also the various reactions that are there, they also can basically go ahead and contribute this. Okay, so these are a few of them, and now what we will do is we will switch over to the two-dimensional diagram and then properly write down that equation. Okay, so let's have a look here. So here is your two-dimensional diagram. Okay, and we will see how to take moments about the y-axis. So this is, as I said, from the front view, and your y-axis is nothing but a dot here. Okay, so here we see that you got px multiplied by h. Okay, so what we can do here, we can write down what are the clockwise and what are the anti-clockwise moments. So the first one here is px multiplied by h. Okay, also similarly, because your px would give you this type of a moment, similarly your pz multiplied by xp, which is right here, would again give you a clockwise moment. This would be pz multiplied by xp. Okay, so that would again give you a clockwise moment. Now let us see what are the other components here. The other component here appears to be the component from q. Okay, so the q again gives about the y-axis a clockwise moment. Okay, so then you've got q multiplied by the distance, and that distance here is zq. Okay, so that distance is zq, which has been given in this particular type of diagram, zq, q multiplied by zq. So these are the ones which are the clockwise moments. Okay, and then we can see that there are some reactions here that are a times xa and c times xc. Okay, so now let us go ahead and see them in the previous diagram. Okay, now let us see here what these moments are. Okay, so these forces, vertical forces A, they are also assumed to have a certain distance from the xyz origin, basically here the yz plane. Okay, so that comes out in the anti-clockwise direction. So I would say A multiplied by xa, and then similarly behind A exactly there would be the force C. Okay, So the force C would somewhere act on this slideway, okay, and A acts here. So when you look from here, you would have them in the same plane. So similarly, C times xc would also be in the anti-clockwise one. So if the clockwise and anti-clockwise moments are added, then you can go ahead and see what is the total equation, okay, and that can be seen right here. Here they have assumed that clockwise moments are positive, anti-clockwise moments are negative, and let us see here. So you've got the first one, you have pz xp component, which we have covered here, right here. Then we have got the px into h. Yeah, so let me try to use a different color here, okay. So your px into h, your px into h is covered up here. Then we have got q times zq. The q times zq has been covered. Similarly, a times xa and c times xc, okay. So when you set this up, this is how your equation basically looks like, and that is your first equation of the moment about the y-axis. We will look at the other equations in our next video. Thank you.